Hi, my name is Anthony Vaudo. Thanks for attending my talk. Today I'll be discussing some of my research at UNR in collaboration with Leonard regarding the nutritional ecology of bee-flower interactions and how it applies to conservation in natural areas. Now, pollination between bees and flowers is an intrinsically fascinating interaction in nature on which the stability of ecosystems often rely. And the focus of our research, or our focus for research and conservation, is based around two main questions. One is what drives bee host plant choice and subsequently pollination success? And two, what maintains bee population stability through adequate nutritional resources? So the central focus to answer these questions is the simple fact that bees visit flowers for food. Nectar is, of course, an extremely important energetic resource for bees, but today I'll be focused on specifically pollen. Of course, pollen is the center of pollination, but it really provides bees' main source of many different nutrients. And this includes fats, proteins, essential sterols, and micronutrients such as vitamins and minerals. But not all pollen is created equal, and they vary a lot in nutritional concentrations. But overall, pollen is very healthful and essential for bees. And we'll be focusing here on proteins and lipids because those are pollen is bees' main source of proteins and fats. And differences in the concentrations between these is linked to bee health and development. So it is necessary for larval growth. It's critical for adult reproduction, such as ovary activation. And pollen proteins and lipids are essential to bee immunocompetence and pathogen resistance as well. And we like to consider pollen in a multidimensional nutritional framework. And when we say multidimensional, it's because pollen quality varies substantially among plant species. On this slide is an analysis of over 80 plant species where each dot represents a different plant species colored by plant family. On the x-axis are protein concentrations of these pollens, and on the y-axis, lipid concentrations. And you can see that they vary widely from high fat, low protein to high protein, low fat. And at any given time, a plant community can provide a spectrum of pollen nutritional resources for bees. Now, how do these differences in pollen affect bee host plant choice and the community interactions? We consider this nutritional geometry, where I'm presenting here a protein and lipid nutritional space. And different plant species can provide pollen with different concentrations of these nutrients in this space, with these lines here representing ratios between proteins and fats of each of these pollen sources. So our previous research showed that many bees, or that bees may have specific or species-specific nutritional needs. And these are represented as nutritional targets here on the graph. And these nutritional targets are basically optimal nutrients for both the adults and their offspring. And there are different strategies on how bees can obtain their optimal nutrition. They can either find a plant that's completely aligned with their nutritional needs, but this isn't always the case in nature, where, like I said before, there's a lot of variation in nutritional quality that bees may not need to actually balance their nutrients by collecting from different pollen sources in order to reach those particular targets. And so therefore, these ratios of nutrients between proteins and fats can really determine how bees interact with the flowers in the community. And so that's what we're seeking to do in our research at UNR. This past summer, I was trying to apply this nutritional framework to entire communities, where I collected data on floral community pollen nutrition and bee visitation records. And I collected from a number of different sites in the eastern Sierras and sagebrush steppe around Reno, ranging from about 1,500 meters to 2,800 meters. And from each of these sites, I collected bee visitation records, and I observed over 4,000 bee visitation events from over 30 genera of bees visiting, uh, I'd say approximately 130 plant species. Currently, still in the process of identifying these bees, but I think there are a couple hundred bee species that we've collected data or foraging preferences from. And also in each one of these areas, we're collecting pollen directly from the flowers and also collecting pollen from bees' legs. And we're going to analyze this pollen for the protein and lipid and protein to lipid ratio nutritional content to see how the nutrition of these flowers structures bee visitation and also be able to calculate bees' nutritional targets. So how do we analyze how pollen nutrition structures bee visitation? We're using these bee flower interaction networks. And this one I'm showing here is an example from preliminary data collected in 2019 from a single site. So here this represents bees observed collecting pollen on the top, and plant species in the community at the bottom, where each bar represents a different species, and the lines connecting the species represents their observed interaction. The thickness of each of these interactions represents the frequency of that interaction among all of the interactions in the community. And from these plant species, we've analyzed the pollen for its protein and lipid concentrations. And here I'll present those species' protein and lipid ratios. And what we can see is that they differ substantially from very high fat, low protein, such as the 0.4 ratio, all the way up to very high protein, low fat, that almost 6-to-1 ratio there. And we can see that the difference in the bee visitation patterns, they do not overlap with all of pollen sources. If we take a look at examples from abundant bee genera, such as the Calliopsis, which is an endrenid genus in green, to our bumblebees in orange, the mason bees in blue, we can see that they differ in their main host plant choice, even if they do overlap. And then based on these frequencies of their pollen collections, we can calculate what their nutritional intake might be. And we can see that the differences in species or genera really differ substantially in nutritional targets. For example, in green, the Calliopsis have high fat, low protein diets, where the bumblebees have higher protein, low fat diets, and even the osmia is foraging from very high protein diets. And this shows that how bee foraging preferences can indicate their nutritional niches and how an entire bee community must be supported by a wide range of pollen sources and nutritional value. So how does this apply to conservation? We say we need to restore a depauperate area and need to know what to plant for floral resources for bees. If we have plants that range in their nutritional values to choose from, and we obtain information on bee nutritional niches as I've described above, we can select plants that are complementary to these bees' nutritional targets by allowing the bees to select and choose from a range of pollen sources. And by incorporating this nutritional diversity into our restoration projects, we, by nature, will include functional diversity and species diversity of plants, and as well, it'll attract functional and species diversity of bees. And hopefully with that, we can encourage a stable plant pollinator community. We can take even a broader perspective and use this concept taking into account bees' entire life histories to provide the resources that they need. And this would be matching phenology such that the blooming periods of the plants match with bee activity periods, also providing nectar resources for bees so that they can fuel their foraging efforts, providing the necessary pollen resources, as we've discussed during this presentation, that are necessary for reproduction and development, and finally preserving the necessary nesting habitat for brood development and overwintering of the bees. For those that are attending the Steward Circle for Pollinator Considerations in Natural Areas, I'll be moderating that discussion. And I think it would be nice to think of these three main questions for our discussion. One of them is, what are the main threats to bee populations in natural areas? I think it'd be really nice to hear what the variety of opinions of this is. And then for me, it's very interesting to know what research would be needed to address these threats. And finally, what are actual feasible implementations of our research to promote population stability of bees and host plant populations? So that concludes my presentation, and I thank you a lot for having me. And I also like to thank my collaborators and assistants for helping with me with my research. Thanks so much.